Okay, naming alkenols, those compounds that contain alkenes and alcohols. The first thing we have to do for any molecule like this is figure out the longest carbon chain. And in this case, this is 1, 2, 3, 4, 5, 6, 7, 8 carbons, suggesting octane. Now, one question might be, well, why did you start here? Why not start here? Well, I started here because it's the side closest to the alcohol. Alcohols have higher priority than alkenes do, so you always want the lowest number for the alcohol. Therefore, this gives the alcohol carbon 3 and the alkene carbon 5. So we said the carbon chain is 5 carbons long, is 8 carbons long, there's an alkene and there's an alcohol. So this is the basis of the name here, and we're going to fill in the numbers and get the complete name. We said the alcohol was on carbon 3. So therefore, I want to make sure that I put the 3 locator right in front of the piece it's referencing, which is the alcohol. If I put the 3 anywhere else, I could confuse the reader as to what the 3 actually refers to. The alkene is on carbon 5, so I'm going to do exactly the same thing there. I'm going to put the 5 right in front of the ene portion of the name, so the reader can tell the 5 refers to the alkene. There is also the fact that I have a methyl group here on carbon 6, so therefore I want to make sure that I put that on as well. So therefore the name here becomes 6-methyl oct 5-ene 3-ol. However, the name's not complete yet because I've got to figure out the stereochemistry about the double bond, in other words, E or Z. So I'm going to use the Carr-Ingel-Prelog rules we've seen before to determine this. And we'll look at this carbon first. Coming off that carbon is a carbon and a carbon. We can't make any priority differences there. So let's look at the atoms coming off those 2 carbons. For the methyl carbon, I actually have 3 hydrogens coming off it. For the ethyl carbon, I have the 2 hydrogens I'm drawing and another carbon. So if I can't make any justification based on these 2 carbons, I move to the next biggest atom, which is hydrogen and carbon. Now here there is a difference. Carbon has a higher atomic number than hydrogen, therefore my ethyl group has priority over the methyl group. Now we're going to move to the other side of the molecule, the other side of the double bond, and do exactly the same thing. There's this group with our alcohol in it, and there is a hydrogen. We're going to apply exactly the same Carr-Ingel-Prelog rules and say, well, coming off the double bond carbon is a hydrogen and a carbon. Carbon has higher priority, or carbon has a higher atomic number than hydrogen, therefore this group has priority over hydrogen, therefore I'll put the star here. These 2 stars are on the same side of the double bond, meaning this double bond is classified as Z. Therefore, the complete name for this alkenol is Z 6-methyl oct 5-ene 3-ol.